Alright, what's going on, everybody? This video we are going to look at calculus with parametric equations. Alright, so let's go ahead and get started. So let's look at tangents. So suppose f and g are differentiable functions, and that should be an and we want to find the tangent line at a point on the parametric curve x equal f of t and y equals g of t, where y is also a differentiable function of x. Then the chain rule gives us dy dt is equal to dy dx times dx dt. If dx dt does not equal 0, we can solve for dy dx, and so we get dy dx is equal to dy over dy dt over dx dt. All I did is up here I just divided both sides by dx dt, and of course that's if dx dt does not equal 0. So this is the derivative. Dy dx is equal to dy dt over dx dt. This is what you'll use this to find your derivative, dy dx. Alright, so let's go ahead and get started on the well, before we get to our example, we'll also need to know how to find the second derivative. So the second derivative of y with respect to x is the derivative of dy dx with respect to t over dx dt. Alright, so this is your second derivative, and we're going to do examples of both in this first example here, finding the derivative. So we have a curve C is defined by the parametric equations x equal t squared and y equals t cubed minus 3t. And they want us to show that C has two tangents at the given point 3, 0, and find their equations. All right, so we want to find the tangent lines also. So first, let's show that C has two tangents at the given point 3, 0. So how in the world are we gonna do that? Well, you see we've got the point 3, 0, this 0 here. So we're going to take the y, because this is your y coordinate, right? We're going to take the y coordinate, t cubed minus 3t, and we're going to set that equal to 0, and we're going to solve for t. So I get t times t squared minus 3 equals 0. So t equals 0, or t squared minus 3 equals 0. So that would give me t equals plus or minus the square root of 3. All right. Now, how do we show that there's two tangents there? Well, let me show you. So, of course, if t is 0, we're going to get 0 and we're going to get 0. We're going to get the point. We'll get the point for t equals 0. We will get the point 0, 0. See, if we take 0 and plug it in here, 0 squared is 0, so our x coordinate is 0. And then if we take the 0 and plug it in for t right here, we're going to get 0 cubed minus 3 times 0, which y is 0. We get that. But look at this. When t is equal to negative square root of 3, that's going to give us what? X is equal to negative square root of 3 squared, which is 3, and y is equal to, that's going to be what? Negative square root of 3 cubed minus 3 times negative square root of 3. So what do we get when we do this? Well, this is going to give us 0. Okay, and you can plug it in your calculator and verify it, but that'll give you 0. And so you can see that gives us the point 3, 0. And then when t is equal to positive square root of 3, we get x equal the square root of 3 squared, which is 3, and y is equal to the square root of 3 cubed minus 3 times square root of 3, which that's going to give us 0 also, and you can verify with your calculator. So we get the 0.30. Okay. So what that shows us is that this point right here comes from two different values of t. Okay, this tells us that the graph C crosses itself at 3, 0. Okay, because when t is negative square root of 3, we're at this point. When t equals square root of 3, we're at this point. So that shows us there that it crosses itself. All right, so that answers that question. All right, so now find the points on, well, I'm sorry, we're not finished with this one. They want us to find the equation of the tangent line. Now, what do we need to find the equation of the tangent line? Well, you remember that from Calculus 1, okay? You got to have what? You got to have a point, and you got to have the slope, okay? You got to have a point, and you got to have the slope. Well, do we have a point? Yes. So remember, we're finding two equations. We're finding the equation when t equals negative square root of 3 and when t equals square root of 3. So it's like two different problems. So let's do this problem here. Let's do it first when t is negative square root of 3. All right. All right, so the first thing we need to do is we need to find the slope, because we already have a point, don't we? We've got the point 3, 0. All right, so let's find the slope. So we need dy dx is equal to, so remember what that's equal to. That's equal to dy dt over dx dt. All right, so let me let's see, let's see if I can move this down a little bit. All right, so what I want to do is I want to write down the equations again. I'm going to just copy these down again. So I've got x equal t squared, and I've got y equals t cubed minus 3t. I'm just writing them down so we can see them. All right, so it's the derivative of this with respect to t, see dy dt. So that's going to be 3t squared minus 3 over, and then the derivative of x with respect to t, which is 2t. All right, so let's do a little bit of simplification here. So I'm going to factor out a 3, and that's over 2t. And then let's write it as 3/2 times t squared minus 1 over t. And so this is going to be 3/2 times t squared over t minus 1 over t. And so this is 3/2 times t minus 1 over t. All right, so there's our derivative. Now we need what? We need the slope when t equals negative square root of 3. Remember I said we're going to do this one first. So when t equals negative square root of 3, all right, that's going to give me dy dx is equal to, so I'm going to take the negative square root of 3 and I'm going to plug it into here, into this right here. So I get 3/2 times negative square root of 3 minus 1 over negative square root of 3. All right, which this minus and minus, that's going to make it a positive. Okay. All right, so now we got what? 3/2 times, and then when I get a common denominator, okay, get a common denominator, that's going to give me, what is that? -3. See, that's over 1, so that's going to be square root of 3. So square root of 3 times square root of 3 is 3, and then the negative, and that's going to be plus 1 over the square root of 3. And so that's going to be negative 2. So that's 3/2 times negative 2 over square root of 3, which is negative 3 over square root of 3, which is negative 3 square root of 3 over 3, which this is just going to give me negative square root of 3. I think I'm still on the screen. All right, so there's our slope. Okay, that's the slope for t equals negative square root of 3. And remember, our point is 3, 0. Okay, that's our xy, right? 3, 0. This is x, this is y. All right, so now what about when t equals square root of 3? Well, dy dx is equal to 3/2 times square root of 3 minus 1 over square root of 3. I'm going to go ahead and find the slope for positive square root of 3 while I'm at it. And look, I'm not going to go through all this again. It's the same thing, but what you would end up with is square root of 3. Okay, so just once again, keep in mind, I'm going through working two problems. It's like I'm working two problems. I'm finding two equations. All right, I'm doing it for negative square root of 3 when t is negative square root of 3 and when t is positive square root of 3. All right, I just went ahead and found both slopes. All right, so now I've got y minus y1 equals m times x minus x1. Okay, and once again, let me just write my point down here, because I'm going to have to push the screen up. All right, and so now we just plug everything in. See, I'm going to plug 0 in for y1, 3 in for x1, and negative square root of 3 in for my slope. So y minus 0 equals negative square root of 3 times x minus 3. And so y is negative square root of 3x plus 3 square root of 3. And there's the equation of my tangent line when t equals negative square root of 3. And then the same thing, y minus y1 equals m times x minus x1. Same thing, I'm going to do it now for t equals square root of 3. All right. So now we've got y minus 0 equals square root of 3 times x minus 3. And so y equals square root of 3x minus 3 square root of 3. And there's the equation of my tangent line. All right. So that's the two problems that we, for part A. Okay, this is a long problem. It asks us to find a bunch of different things. All right, so we showed that C has two tangents at the point 3, 0 by setting y equal to 0 and solving. All right, and we got negative square root of 3 and positive square root of 3. That gave us, each of those t values gave us the point 3, 0. So that tells us it crosses itself. And then we found the equation of the two tangent lines, okay, by finding the derivative, getting the slope, and all that good stuff. All right, now it says find the points on C where the tangent is horizontal or vertical. All right, so let's do that. All right, so how do we determine when the tangents are horizontal or when they're vertical? Well, first, let's write down the derivative again. Remember, that's dy dt over dx dt. Okay, and remember, that was 3t squared minus 3 over 2t. And yes, I know we simplified it earlier. Okay, we simplified it earlier up here. Where is it? Right here. Remember, we did the dy dt over dx dt, and we went through and simplified it and everything for our derivative. But let's think about this a little bit. Yes, we can go through and simplify it, but you know, let's hold off on that just real quick. So think about it. When is the tangent line? When is it horizontal? Well, that would be what? When dy dt is equal to 0. It's when dy dt is equal to 0, but dx dt cannot be 0. Okay? So when is dy dt equal to 0? So right now we're dealing with the horizontal tangents. Okay? So when is dy dt equal to 0? Well, that's 3t squared minus 3 equals 0. So that's going to be what? That's going to give us t squared equals plus or minus 1, right? When we solve it. Okay. So when t is plus or minus 1, that's when we're going to have a horizontal tangent. So what points does that correspond to? Well, when t equals -1, we get x is equal to what? Now remember in our problem, let me write it right here, x is equal to t squared, and y was equal to what? T cubed, and what's it? Minus 3t. I believe that's the problem. Yeah. So here's our original problem, right? Our parametric equations. So x is equal to -1 squared, which is equal to 1, and y is equal to -1 cubed minus 3 times -1, which is equal to 2. So that would be at the point 1, 2. We have a horizontal tangent. And then when t equals 1, well, x is equal to 1 squared, which is 1, and y is equal to 1 cubed minus 3 times 1, which is -2. And so we have a horizontal tangent at 1, 2. All right. So that's pretty easy. Okay, that's not bad. So that's our horizontal tangents. Now let's find our vertical tangents. Well, where are our tangent lines vertical? Well, that's at what? That's when dx dt equals 0. So horizontal tangents, that's when dy dt equals 0, and dx dt does not equal 0. And then the vertical tangents, that's when dx dt is equal to 0. So let's take dx dt. See, dx dt is 2t. That equals 0. That means t is equal to 0. So we have a vertical tangent when t equals 0. Or do we? So why did I ask that question? Do we have a vertical tangent there? Well, if you remember, okay, if you remember on back when you were doing calculus and you were doing horizontal and vertical asymptotes, okay, that was back in the chapter when you were doing limits. Remember, to verify that you had a vertical asymptote, you had to show that the limit of the function as x approached the number from the left or the right, or just approached the number, equal to infinity or negative infinity. Remember that? So let's verify that this is a vertical tangent here. So how are we going to do that? Well, I'm going to take the limit as t goes to 0, and I'll go t goes to 0 from the right. okay, of 3t squared minus 3 over 2t. This right here just goes back to what you had to do in Calculus 1, okay? So let's look at this. If I'm coming into 0 from the right-hand side, okay, do you understand that the numerator, the closer and closer I get to 0, the numerator is pretty much going to be -3, okay, because this term here is going to 0. But this term down here, what's happening to it? Well, it's getting smaller and smaller and smaller. So if I have -3 over a really, really small number, then where's that going? That's going to -infinity. So I have a vertical tangent at t equals 0. So for t equals 0, I get x is equal to what? 0 squared. See, I'm just taking the t and I'm plugging it into here, and then I'm going to plug it into here to get my y, just like I did over here when t equals -1 and 1. I took the -1 and the 1, I plugged it in for t in x and t for y, and that gave me the 2 points. Now I'm going to do the same thing here. And so y is equal to 0 cubed minus 3 times 0, which is 0. So I have a vertical tangent at the point 0, 0. I've got a vertical tangent there. All right, and that's what they were wanting us to find there. All right, now let's go to part C. It says determine where the curve is concave upward or downward. All right, so what does that entail? Concave up, concave down. That deals with what? The second derivative, right? That deals with the second derivative. All right, so let's go ahead and write our dy dx. We know that dy dx, that was equal to 3/2 times, let's see, I need to go back up here and look again. Dy dx is 3/2 times t minus 1 over t. 3/2 times t minus 1 over t. That's our derivative, okay? So remember, the second derivative, okay, the second derivative was what? d dt of dy dx over dx dt. All right, so what does this mean? All right, so right now, just disregard the denominator, okay? Let's just look at the numerator, okay? Let's look at the numerator. To get the numerator, that tells me what? That tells me I'm taking the derivative of dy dx, which is this thing. I'm taking the derivative of this with respect to t. You see that? All right, so let's take the derivative of this with respect to t. So that's going to be 3/2 times the derivative of t is 1 minus, and then what's the derivative of 1 over t? Well, the derivative of 1 over t is -1 over t squared. Okay, and you can verify that. Remember, that's 1 over t is t to the -1, then you just use the power rule. All right, so the derivative of this thing right here is -1 over t squared. So the negative and the negative, that's going to make a positive. So plus 1 over t squared. All right. And then this is over, see, this right here is this numerator right here. And then the denominator is what? dx dt. Okay? All right. So once again, let me write down x equal t squared and y is equal to t cubed minus 3t. I'm just writing the problem down again. All right, so I need dx dt. So what is dx dt? Well, that's the derivative of x with respect to t right here. So the derivative of this is just what? 2t. All right. All right, so now let's go ahead and simplify this. So this is going to be 3/2 times, now remember this is 1 over 1, so this is going to be t squared plus 1 over t squared over 2t, which that's going to be 3 times t squared plus 1 over 2t squared over 2t. All right. Now remember, this is over 1, so this is going to be 3 times t squared plus 1 over 2t squared times the reciprocal of this, right? Times 1 over 2t, which is going to be 3 times t squared plus 1 over 4t cubed. All right, so there's my second derivative. All right, so what do I do now? You remember what you did for concavity? We want to know when this thing's 0, right? Well, it's never going to be 0, because remember, a fraction is 0 when the numerator's 0. Well, that's not going to happen. This will never be 0. That's t squared plus 1. That's never going to be 0. I mean, you can, and just to show you, this is, if you set this equal to 0, you get t squared equals -1, so t is equal to plus or minus I. It's an imaginary number. It's never going to be 0. But it is undefined at t equals 0. So that's what we're going to use there. Look at this. You've got t equals 0 here, right? And so if I do t equals -1, t equals +1, well, look at this. When t is -1, well, the numerator up here, that's going to always be positive. So if I plug the -1 in here, this is going to be positive over a negative, which is negative. That tells me it's concave down. And when I plug the 1 in right here, this is going to be positive. This is going to be positive. So this is going to be concave up. So it's concave down from -infinity to 0, and concave up from 0 to infinity. So there's your concavity. All right. And that's all they were wanting to know. Determine whether the curve is concave upward or concave downward. All right. So what does the last part say? It says sketch the curve. Okay. So before we sketch the curve, let's write down the important information that we found up here. Okay, I'm going to pause the video while I do it. All right, so we have everything written down here. So let's see if we can't sketch the graph here. All right, so I wrote down all my important points, that we found earlier. Oh, and also we know it's concave down from -infinity to 0, and concave up from 0 to infinity. All right, so let's mark this off. So we got 1, 2, 3, 1, 2, 1, 2. All right, so I'm going to plot my points. So I got the point 0, 0, and that is when t equals 0. I got the point 1, 2, and that's when t equals -1. I got the point 1, -2. That's when t equals 1. I've got the point 3, 0, and that's when t is equal to plus or minus square root of 3. That's where it's going to cross itself, right? All right, so how am I gonna draw this? Well, you've got you've got t equals -1, and you see the t is negative, and see when it's negative, it's concave down. So basically what's going to happen is this graph is going to look like this, and see how t is positive, it's concave up, and so it's going to look like this, and it's going to continue this way, and it goes like this. This is where it crosses itself. Okay, now we've got to figure out the direction of this thing. Okay, so if you look at this, see how t is -1, I get this point, t is 0, I get this point, and then when I go to t equals 1, it goes to this point. You see how it's kind of following along this path right here. And then the same thing here when t is negative square root of 3, and t is positive square root of 3, it's just continuing on like this. And it's gonna, it's not gonna, you can see here t is -1, t is 0. You can see it's moving this way. This graph is not going to go here and then turn back around and stuff like that. So we can see this is the path that it's following right here. Okay, and that's the graph of it. All right. So yeah, that was a pretty long example there, but hopefully it all made sense. All right, let's do some more. We got another example here. It says, find the tangent to the cycloid x equals r times theta minus sine theta, y equals r times 1 minus cosine theta at the point where theta equals pi over 3. Okay. All right, so what do we have? Well, let's find dy dx. Remember, that is dy dt over dx dt. So what's dy dt? Well, that's going to be r times what? Well, what's the derivative? Well, I'm sorry, we're over here. R times what's the derivative of 1? 0. What minus, okay, minus the derivative of cosine. What's the derivative of cosine? Negative sine, right? Derivative of cosine is negative sine, positive, negative and negative make a positive. So that's sine theta. And then what's the derivative of this one? Well, that's going to be r times, what's the derivative of, oh, I'm sorry. Look what I did. It's not dt, it's d theta. That may happen some more in the video. I don't know. You just typically with these parametric equations, you typically see t as the variable. Okay, so I don't know, just wrote t down, but it's dy d theta dx d theta. All right, so the derivative of theta is 1 minus the derivative of sine is cosine. Okay, and so this is going to be sine theta over 1 minus cosine theta. There's your derivative. All right, and remember, they want to know the tangent when theta equals pi over 3. Okay, so for theta equal to pi over 3, we have dy dx is equal to sine of theta, sine of pi over 3 divided by 1 minus cosine of pi over 3. All right. So what's the sine of pi over 3? That's square root of 3 over 2 over 1 minus, and then the cosine of pi over 3 is 1/2. Yes, the square root of 3 over 2 and the 1/2, that is something you should know from trig. All right. And now let's simplify this thing. Remember back in algebra how you can simplify complex fractions? Look at everything as a fraction. So I'm going to multiply everything by the common denominator, and that's going to give me square root of 3 over, what is that, 2 minus 1, which is just square root of 3. That is what? That's the slope of our line. Okay? Now, what do we need now? Okay, what do we need now? We need a point, don't we? We need our XY point. Okay, they give us theta, so we can find the X coordinate and we can find the Y coordinate for that. So let's do that. And I think what I'm going to do here is I'm going to take these and I'm going to move it right here. All right. Just so we can see the equations. All right, so I've got X is equal to R times what? Times pi over 3 minus sine of pi over 3. Okay, that's my X. And so that's going to be R times pi over 3 minus, and what's the sine of pi over 3? That's square root of 3 over 2. Okay, so there's my X coordinate. Now, what is my Y coordinate? Well, now I got to put pi over 3 into here. So that's going to be R times 1 minus cosine of pi over 3. Because remember, when you're finding a tangent line, you got to have the slope and you got to have a point. We found the slope, which is right here. Now we got to find the point. So we got to take theta, plug it in here and here to get our X and Y. So that's going to be R times, wait a minute. Never mind. I thought I wrote something down wrong, but I didn't. All right, and that's going to be 1 minus, and then the cosine of pi over 3 is 1/2, and so that's going to be R times 1/2, which is R over 2. So there's our point. All right, so remember our slope is square root of 3, and our point is R pi over 3 minus square root of 3 over 2, R over 2. There's our point. This is our X, this is our Y coordinate. And so now I can use Y minus Y1 equals M times X minus X1. And so that is going to give me Y minus R over 2 equals square root of 3 times X minus R times pi over 3 minus square root of 3 over 2. And, I don't know, does your teacher want you to leave it like that? I have no idea. What I'm going to do, I'm going to go ahead and just solve this thing for R. Okay? And so I get Y minus R, I'm sorry, not for R, but for Y, equals, let's just do it like this, minus R square root of 3 times pi over 3 minus square root of 3 over 2. So I just distributed that square root of 3, and now I'm going to distribute this to each one. And so Y minus R over 2 equals square root of 3x. That's going to be minus R pi square root of 3 over 3 minus, what is that, 3/2? Is that 3/2 R, I believe? I think so. Yeah. Just making sure I don't write anything down wrong, that's all. And then I'm going to add R over 2 to both sides. So Y equals square root of 3x minus R pi square root of 3 over 3, I'm sorry, the negative and negative, that should be plus. And so r over 2, 3r over 2 plus r over 2 is 4r over 2, right? See, 3r over 2 plus r over 2 is 4r over 2, which is 2r. And so that's plus 2r. And there is your equation. Okay. Okay, and they have a part B for us also. Okay, so but there's the equation of your tangent line. Okay. All right, and part B, at what points is the tangent horizontal? When is it vertical? Okay, so we did that before. Okay, we did that before. So let's go up here and grab, well, I can just write the equations down again. All right, so I've got the equations written down again. So let's find when the tangent is horizontal and when it's vertical. All right, so just real quick, let me just draw a quick graph, and I'm actually going to move this down here, and I'm gonna put the graph up here. Now, I'm not going to go through how to graph this thing. This is a cycloid. It's going to look like this. The previous section in your book would go over this. This is actually negative 2 pi r. We got 0, we got 2 pi r, we got 4 pi r, and we got 6 pi r. And then these points right here, well, I'm gonna show you. You can see these points here. This is where you're up. This is where your horizontal tangents would be, right here. You see that? Okay. And where would your vertical tangents be? They would be like right here would be your vertical tangents. Okay. But what we're going to do is we're going to find those. Okay. All right. So remember, your horizontal tangents, that's when dy d theta, in this case dy d theta, when that is equal to 0, and then when dy d theta is equal to 0, but dx d theta is not equal to 0. That's your horizontal tangents. And then your vertical tangent would be when dx d theta is equal to 0. So let's go ahead and do dy d theta. And so remember, we found that before. That's r times sine theta, which is r sine theta. Okay. So when is dy d theta, when is that equal to 0? Well, that's when sine theta is 0. So when sine theta is equal to 0, oh goodness, do we remember how to do that? Now if we look there, 0, 2 pi. That's something that you should be able to do real quick. Is sketch a basic sine and cosine curve. Okay, you should be able to do that. All right, so we can see that sine is 0 at 0, pi, 2 pi, and so on. So that almost tells us that, hey, sine is 0, which is dy d theta, well, without the r, but sine theta is 0 at all the multiples of pi. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, negative pi, negative 2 pi, negative 3 pi, and so on. But this is when theta is equal to 2n minus 1 pi. All right. And n is an integer. So what is that doing? Well, that's giving us, this right here is giving us 1 pi, 3 pi, 5 pi, and so on. It's giving us the odd multiples of pi. It's not giving us 2 pi or 4 pi or 6 pi, but sine is 0 there, isn't it? You see that? Sine is 0 there. Well, let's look at this. What's dx d theta? That's going to be r times 1 minus cosine theta, right? Well, let's look at this. Let's just take the 2 pi. Okay, let's take 2 pi and plug it in. What's the cosine of 2 pi? Remember, the graph of cosine would look something like this in red. Well, the cosine of 2 pi is 1. What's 1 minus 1? 0. So we cannot include those values. We can't include the even multiples of pi, because remember, there's a horizontal tangent when dy d theta is 0, but dx d theta cannot be 0. So that's why we're only including the odd multiples of pi. Okay, does that make sense? All right. So that's where we have our horizontal tangents. Okay, that's our horizontal tangents. Now, and let me just label this HT, that's our horizontal tangent, and then let's label this vertical tangent. So remember, the vertical tangent, that's where dx d theta is equal to 0. Well, we don't have to worry about the r. That's just when the 1 minus cosine theta is equal to 0, which tells me cosine theta equals 1. Now, where does cosine theta equal 1? Well, let's just look. Just sketch the graph if you need to. That's the easiest thing to do. Just graph one cycle of it. And so we know there's cosine, right? There's cosine. So let's look at this. So when is cosine 1? Well, we can see it 0, 2 pi, and I wonder what else. 4 pi, 6 pi, 8 pi, and so on. And then also negative 2 pi, negative 4 pi, negative 6 pi. See, we want to know when cosine theta equals 1. So that's going to be at even multiples of pi. So that's when theta is equal to 2n. Is equal to 2n pi. Well, before we go and look at that, let's see if we can't verify that. Okay. All right. Now remember what we did earlier. Well, how about we go back up here and let's label the graphs here. Okay. So, right here we're at 2 pi r. What are these? What's this value right here? This is the value pi r, and then what? 2r. That would be that value, right? This is pi. Okay, so let me show you how I get this point right here. Okay, let me just show you. So this right here would be at pi r, right? That's pi r. Well, let me just show you. So when theta is pi, what happens? So when theta is equal to pi, we get x is equal, now I'm plugging it into here, that's r times pi minus sine of pi. Well, what's the sine of pi? The sine of pi is 0, so that's just pi times r. That's your x coordinate. And then your y coordinate, plug pi into here. Well, that would be r times 1 minus cosine pi, which is r times, that's what, 1 minus, what's cosine of pi? -1. And so that would just give us 1 plus 1 is 2, 2r. Okay, and that's how all of these would be. And then you could do 3 pi r, 2r. I mean, all the y values are going to be that. And then you've got 5 pi r, 2r. And you would just take 3 pi, plug it in for x and y to get that. And then you've got negative pi r, and then you've got 2r. All right, so let's see if we can't verify that we have vertical tangents there. Let's look at this right here, this 2 pi r. Okay, when we've got 2 pi r here. Well, I'll tell you what, let's do the 2n pi. Okay, let's look at 2n pi, what we got here for theta. So I've got the limit as theta goes to 2n pi, and that's going to go from what? That's going to, let's just go from the right, okay, of 2n pi, of what? Of dy dx. All right, that's what we're doing, dy dx. Now, do you remember what dy dx? See, we're verifying that this is a vertical tangent, just like we did in the first problem where you got to do that limit. And so remember what dy dx is. Dy dx is this, sine theta over 1 minus cosine theta. So that's going to be sine theta over 1 minus cosine theta. All right, so let's see what we get here. Well, this is, if I do the sine of 2n pi, okay? So remember, the sine of 2n pi, that sine is going to be 0 there. And then cosine of 2n pi, so the cosine of 2 pi, 4 pi, and so on is 1. That's 1 minus 1. That's 0. I've got 0 over 0. So what do we do now? Okay, what do we do with that? Well, let's see. I left off the limit. This theta goes to 2n pi from the right of sine theta over 1 minus cosine theta. I forgot to write the limit in front. Well, what do I have? Well, that's the limit as theta goes to 2n pi from the right. 0 over 0, that's what? Cosine theta over what? Sine theta. I can use L'Hopital's rule. Okay, so now this is equal, and I'm coming in from the right, okay, 2n pi. All right, so what's cosine at 2 pi, 4 pi, 6 pi? That's pretty much 1, right? And then the sine, if I'm coming in, okay, if I'm coming in from the right of 2n pi, okay, be like 0. Okay, let's just look 0. So if I'm coming in to 0 from the right hand side on the sine function, my y value is getting smaller and smaller, right? It's getting smaller and smaller. So this is pretty much 1 up here. It's going to 0 here. That's going to infinity. So that verifies that I have my vertical tangents at 0 at theta equals 2n pi. My horizontal tangents are here at 2n minus 1 pi, where n is an integer. And same thing here, n is an integer. Okay. Now, and I hope you understand why we didn't include the even numbers here, okay, because that made dx dt 0 also. All right. So, you know, it's the problems really aren't that difficult as far as the calculus part of it goes. I think what's going to stump most students up is having to think about all the trig stuff. So you've got to be, you know, for this problem, you got to be up on your trig. So, all right. So I think we've got a few more examples to do. All right. So it says find the area under one arch of the cycloid. Okay. So let's look at this. It says if the area is traced out once by the parametric equations x equal f of t and y equals g of t, and t is between alpha and beta, then we can calculate an area formula. A is equal to g of t times f prime of t dt from alpha to beta. Okay. All right. So what I want to do here is I want to let me go and I want to trace out this. I want to bring this. See if I can't bring this down. It'll let me. All right, so there we go. All right, so let's just look at this. All right, so I want the area under one arch of the cycloid. So understand, I mean, it's the same equations as in the earlier, okay, as in the earlier functions. All right, so what do I need? Well, I've got x equals r times theta minus sine theta, y equals r times 1 minus cosine theta. And remember, this is g of t, this is f of t. So what do I get? I've got to do g of t. What do I get f prime of t? Well, let's see. F prime of t, that's just the derivative of this. That's r times 1 minus cosine theta. That's f prime of t. And then I know my formula, the area for my formula is this. See that right there? That is alpha to beta, and then it was what? G of t times f prime of t. G of t times f prime of t dt. All right. So this is going to be g of t, which that's going to be r times 1 minus cosine theta. Okay, I got that from here. That's g of t. And then times f prime of t, which is this. So that's times r times 1 minus cosine theta. Okay, d theta. And yes, I know I've got g of t, f prime of t, dt. And all I did, I wrote the formula down, but understand that our variable, we're not t, we're in theta. So it's theta instead of t. All right, so, and I'm going to go from what? I'm going to go from 0. Now, remember up above when I showed you about getting these points? Okay, so theta is between alpha and beta. Remember that? See, your variable, the t, see the t, in our case, theta is between alpha and beta. So here's one arch of the cycloid. and I'm going to go from 0. Now, how do I get 0? Well, remember, that's from taking this and plugging it into here and here, okay? And then I'm going to take what? How did I get this? I plugged in pi. How do I get this? I plugged in 2 pi. Theta was 2 pi. So I'm going from 0 to 2 pi. And so now I get r squared. R times r is r squared, right? I'm going to bring that outside the integral, 0 to 2 pi. And that's going to be 1 minus cosine theta squared times d theta, which is r squared, 0 to 2 pi. And that's going to be 1 minus 2 cosine theta plus cosine squared theta. And that's d theta. Well, that's a long video, isn't it? Okay, well, that's fine. All right, so that's going to be r squared times 0 to 2 pi, and that's going to be times 1 minus 2 cosine theta plus, okay, here we go. Cosine squared theta. Do you remember how to do that? That is from what? That's from when you did your trigonometric integrals. We're going to use the half angle identity for cosine. Remember, it was 1/2 times 1 plus cosine 2 theta. You know, if you have to go back and review those identities, go back and look at that section on trigonometric identities. I bet there's an example in the textbook on that. All right, and so that is going to give us, let's see, that's going to be r squared, 0 to 2 pi. All right, so let's distribute the 1/2. So that's going to be 1/2. 1/2 plus 1 is 3/2 minus 2 cosine theta plus 1/2 cosine 2 theta d theta. Now, remember these two here, they're easy to integrate. This one, remember, you can go and use the u substitution, let u equal 2 theta, du equals 2 d theta. Do your u substitution on that one. I'm not going to go through and do it because I'm just not, okay? You should know how to do that. So that's going to be r squared, okay, r squared times, that's going to be 3/2 theta minus 2 sine theta. I'm integrating now. And then once you do your u substitution and integrate all that, that's 1/4 sine 2 theta, and that's from 0 to 2 pi. All right. And then you plug in everything. Okay, so let's look at this. This is easy. You don't even need to write this out. This is going to be r squared times 3/2 times 2 pi. And that's all you need. Okay, so think about this. When you take the 2 pi and you plug it in, there's your 3/2 times 2 pi. What's the sign of 2 pi? It's 0. So there's not going to be anything else. And then you've got to do, remember, minus, and then you plug the 0 in. All those are going to be 0. So that's all you have right there. And so your final answer is 3 pi r squared. And so there's your area. Okay. All right. Let's look at another example. Oh, we got us a theorem here. All right. So I've got, if a curve C is described by the parametric equations x equal f of t, y equals g of t, t is between alpha and beta, where f prime and g prime are continuous, and, I don't know why I left off the d, and continuous, and the interval alpha, I think that should be not and, are continuous and in the interval alpha to beta, and C is traversed exactly once as t increases from alpha to beta, then the length of C is this. So this is how you find the length of the curve. It's just dx dt squared plus dy dt squared, the square root of all that, and then you have to integrate it. All right, so let's go ahead and let's do it. I mean, this is easy. And we want to do one arch of the cycloid. So I'm not going to go through and explain all this again, but remember how we did this when we did one arch. We got our 0 to 2 pi. That's going to be the same limits, okay? And remember, it wouldn't matter if you went from 2 pi to 4 pi, okay? You could do that and you would get the same answer. We're just picking this one because it's 0 to 2 pi. All right, so we're going to do the same thing on this one. All right, so I need what? I need dx dt. That's going to be r times 1 minus cosine theta, and dy dt is equal to r sine theta. All right, so there we go. All right, so the length is going to be from 0 to 2 pi, and I explained in the previous problem how we got that. We're doing one arch, and that's going to be r times 1 minus cosine theta squared plus r times sine theta squared, and it is the square root of all that, d theta. All right, so this is going to be from 0 to 2 pi, and this is going to be the square root of r squared times, times 1 minus cosine theta squared plus r squared sine squared theta d theta. All right, so let's do this. Let's multiply this out. That's going to be r times 0 to 2 pi. Uh-oh. Where did that r come from? You see the r squared? I just factored that out. And what's the square root of r squared? R. And so I just brought it outside. So now let's multiply that out. 1 minus cosine, 1 minus 2 cosine theta plus cosine squared theta plus sine squared theta d theta. All right, so we're getting there. All right, so look, remember that right there is 1, and so that's going to be r0 2 pi square root. That's 1 plus 1 is 2 minus 2 cosine theta d theta, which that's going to be r0 to 2 pi, the square root of 2 times 1 minus cosine theta d theta. Okay. Now, how in the world do I integrate that thing? All right, let's look. All right, so let's jot down some stuff that we're supposed to know. Okay, so let's do it in, I guess we'll do it in red. Let's do a note here. Okay, so if you're taking notes, you'll have this to go back and look at. Remember, sine squared theta is equal to 1/2 times 1 minus cosine 2 theta. All right. So what made me think of that? Well, what made me think of that is that this 1 minus cosine, I need another parenthesis there, that this 1 minus cosine theta looks a lot like that right there. And I knew that this is sine squared. Okay? And, same thing, if it was a plus, we would have cosine squared. What's so great about sine squared, cosine squared having that? Well, when I take the square root of that, the square root's gone now. And then I can probably integrate it pretty easy. Okay? All right, so what is this? Well, let me show you. Let me show you what we have. We have 1 minus cosine theta, don't we? But what do we need? We need a 1/2 here, don't we? So we can do that. I can multiply that by 1/2, but then at the same time, I have to multiply by 2. Remember, we can do that. We can multiply by 1. That's what that is. All right. So that is going to give us the 2 here. And then what is this? Okay. That is going to give us our sine squared. Okay. Now, look at this. You see we're in this part of it. You see the 2 theta. What's that angle? Theta. You see that? This is 2 theta. This is theta. This is theta. Remember this angle here. Okay. This angle, you half it to get this angle. So if we take this angle, we're going to half it. That's theta over 2. You see that? All right. So let's continue on. We get r 0 to 2 pi square root of 2. That's that 2 there. Times this 2 sine squared theta over 2 d theta, which is r 0 to 2 pi square root 4 minus sine, not minus. Why did I put a minus? I think this video is going too long. I'm starting to lose my mind a little bit, I guess. Okay. And so look what we have. We have r 0 to 2 pi of square root of 4 is 2. I'm going to bring that out. Sine theta over 2 d theta. And then once again, you can use the u substitution right here. Okay, you can use u substitution. All right, so that's going to be 2r, and that's going to be what? Negative 2 cosine theta over 2 from 0 to 2 pi. And so that is going to give me 2r times negative 2. And then if I plug in cosine, well, let's just go ahead and do it. Cosine of 2 pi over 2 minus, which would be plus because of the minus there, 2 cosine of 0 over 2. That's going to give me 2r times, and then this right here is just going to end up being 2 because that's the cosine of pi is negative 1, negative 1, negative 2 is positive 2, and then plus 2 times, and then the cosine of 0 is 1. 1 times 2 is 2. And so that actually gives us what? 8r is the length of it. All right, so I know this is a long video, but just bear with me. This is the last problem. Okay, the last problem. And I don't think it may not be too bad. We'll see. All right, so now let's look at surface area. So suppose the curve C given by the parametric equations x equal f of t, y equals g of t, where t is between alpha and beta, and where f prime and g of prime are continuous, and g of t is positive. Okay, g of t is positive, is rotated about the x-axis. If C is traversed exactly once as t increases from alpha to beta, then the area of the resulting surface is given by, there you go. There's your formula for surface area. Okay. All right. Now, this is rotated about the x-axis. Yes, the x-axis. It's this formula. It's 2 pi y times this. Now, if it says it's rotated about the y-axis, then this y becomes an x. That would be the difference in the formula. Okay. All right, so let's take a look at this example here. All right, so first thing we need is we need equations. And so we can do that by x is equal to r cosine t, and y is equal to r sine t. Okay, and what we can do is just form, I mean, we know this is a circle, okay? That was from the previous section on parametric equations when we graphed them. That's the video right before this one, okay? So take a look at that when we go over all that, you know, graphing these things. I think we actually may have looked at the graph of this one. But we can take the semicircle and revolve it about the x-axis, and that will create a sphere. Okay, so going from 0 to pi, that's giving us a semicircle, and we're rotating that about the x-axis. So let's see what we need. We need dx dt, see, dx dt and dy dt. So that's going to be negative, that's going to be negative r sine t, and dy dt is r cosine t. And there you go. And you got it now, and we know that y is equal to what? Well, we got it there, but y is equal to r sine t. So we're going to get, let me see if I can't move this down just a little bit so we can see it when we have a little room to write. So I have s is equal to, I didn't get that beta, did I? So s is equal 0 to 2, 0 to pi, see, 0 to pi, we're just doing a semicircle, and that's going to be 2 pi times y. What is y? That's r sine t times the square root of dx dt squared. So that's negative sine t. That's negative r sine t, all of that squared, plus r cosine t, all of that squared, dt. Okay, so that's all I did. I just plugged all that into the formula. All right, so let's hope this turns out pretty good. So I've got s is equal to 0 to pi of 2 pi r sine t times the square root. That's going to be r squared sine squared. Well, this looks good, doesn't it? R squared cosine squared dt. Okay, so factor out r squared. The square root of r squared is r. Okay, well, let's do this. 0 to pi, 2 pi. You'll be able to, I mean, you can probably see it that way, but this right here may help you see it a lot better. I'll go ahead and write it out for you. Okay, what's this? That's 1. So I got the square root of r squared, 0 to pi, 2 pi. That's r. This whole thing here is r, so r times r is r squared sine t dt. And so 2 pi r squared, 0 to pi, sine t dt. Look at that. See how easy that is? And so we get, this is going to be what? 2 pi r squared, that's times what? Negative cosine t from 0 to pi, which that is going to be, let's see. Let me come down here and write it. That's going to be 2 pi r squared times, that's going to be negative cosine pi minus which is plus because that's negative cosine 0. And so this is 2 pi r squared times, well, cosine of pi is -1, negative, that's positive. Cosine of 0 is positive. And so this is actually going to give us what? 4 pi r squared. And there's your surface area. And actually that is that's what they want us to show. That's the surface area. So that's an easy way to find the surface area of a sphere. All right. So you know what? If you're still watching the video, leave it in the comments and let me know. Kind of curious to see how many hung around to the end. If you did, I appreciate it. All right. So hope this video helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see y'all in the next one. Later.